The tuba is the largest instrument in the brass family and the one with the lowest pitch. Famous orchestral composers from Stravinsky to Gershwin have included significant parts for tuba in some of their best-known works. Some composers have even written full concertos for tuba. Tubas are made of brass, sometimes silver or gold-plated. The instrument consists of valves and tubing, ending in a flared bell. The bell flare begins as a brass disc 55 centimeters in diameter. They use a range of tools and various mandrels to work the brass into a preliminary bell flare shape. They use sandpaper to remove any marks left by the tools. Then cut a hole in the center. To make the conical tail that leads to the bell flare, they bend and hammer a thin brass sheet around a tail-shaped mandrel. To join the seam, they cut notches along one edge, then hammer them over the other edge. The artisan then melts filler metal over the seam with a high-temperature gas torch, a process known as brazing. Then they use a wooden mallet to round out the shape. They use a pressure roller to flatten out the mallet dents and further refine the surface. After notching the wider end of the tail, they assemble it to the bell flare. They dab on flux, a chemical that prepares the surface for brazing, then tack the parts together. They hammer down the notches and braze the seam all around. This assembly, now called the bell, goes back on the lathe. Using a belt sander, they flatten all the seams flush with the surface. On another mandrel, with lubricant assisting the process, they finalize the bell's shape. Now they trim the edge to the correct diameter. Bend it back a bit. Polish the perimeter with a sanding head, then use a special tool to roll the edge over itself. This forms what's called the bell bead, a lip that reinforces the bell and gives this end of the instrument a finished look. A computer-guided engraving machine puts the company logo and model number on the bell. Each of the tuba's 100 or so tubes must be bent into a specific shape. The first step is to fill them with hot liquid pitch, which hardens as it cools. This keeps the tubes from collapsing as they're bent. After bending, the tubes go into an oven to melt out the pitch. Certain bent tubes are enlarged in a machine called a hydraulic blowout press. It pumps oil into it at high pressure. This blows the tube walls outward against the die, forcing it to assume the new shape. Certain bent tubes are conical, others cylindrical. The cylindrical ones go through what's called a ball-out operation. This machine forces steel balls of the proper diameter through the tube. This enlarges any spots that are too narrow. Before bending, certain tubes have to go through a drawing machine for resizing. With lubricant easing the way, it draws the tube between an inner mandrel and an outer washer. This forms the tube to the correct diameter and wall thickness, while also stretching it lengthwise. Coming up next, we'll see where this tube fits in the finished instrument. Tubas come in different versions. A B-flat tuba, for example, is nearly 5.5 meters long, whereas an F tuba is about 3.5 meters long. Tubas have anywhere from 3 to 6 valves. Pressing different valve combinations produces different notes. To build the valve section, they insert parts called knuckles into the valve cases. Spacers hold the valve cases the proper distance apart, while this alignment plate positions the cases in the correct configuration. Next, they insert connectors to later link the valve section to the rest of the instrument. After brazing the parts together, they run a cutter through the valve cases to hollow them out. Here, you can see what the case interiors look like before cutting and after. Now they begin soldering on the valve section's tubing, working from the valve cases outward. The Tubas frame section is made up of several U-shaped parts. Workers assemble them with connecting rings. They insert a support brace inside this frame piece. Then position tabs onto which they'll later mount the valve section. They clamp the tabs in place, then solder them on. Then they attach the bell section to the frame. Before adding the valve section, they give a preliminary buffing to what they've assembled so far. They brush some liquid polishing compound into the places that they couldn't access with the wheel, and buff those areas with a rag. Then a final overall buffing, until the brass reflects like a mirror. Meanwhile, the valve section assembly continues. First, they close off the bottom of each valve case with a screw-on cap. Then drop in a spring to provide resistance for the valve piston. Then the piston. A felt to cushion it. A top cap. Another cushioning felt. And finally, the finger button. A little oil ensures all the buttons move smoothly. The felts inside prevent the pistons from making a clanging sound as they move up and down. Now for the tuba's tuning slides. A coat of grease helps them move in and out to increase or decrease the overall length of the tubing. Shortening tunes the instrument higher. Lengthening tunes it lower. Now they screw the finished valve section to the assembled frame and bell sections and insert the main tuning slide. Finally, the tuba's mouth pipe, made not of brass like the rest, but of nickel silver. They spray the entire instrument with cleaning solution to remove any grease residue and fingerprints. Prior to assembly, each section was cleaned and coated with a clear lacquer to ensure the tuba will always look as good as it sounds. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.